Imagine a force of nature so powerful it could alter the course of global climate, darken skies across continents for months, and reshape the very face of our planet. Now, what if I told you that such a force lies dormant beneath the picturesque landscapes of one of America's most beloved national parks? Today, we're diving deep into the world of supervolcanoes, with a special focus on the sleeping giant beneath Yellowstone. But here's the twist. Everything you think you know about these geological titans might just be wrong. Welcome to Artful Dodger, where we unravel the mysteries of our planet. If you're new here, don't forget to subscribe and hit the bell icon for more fascinating content that challenges what you think you know about the world around us. Supervolcanoes are not your average mountain with a smoking top. They're vast volcanic systems capable of eruptions thousands of times more powerful than anything we've seen in recorded history. To put it in perspective, if Mount Vesuvius, which famously destroyed Pompeii, was a firecracker, a supervolcano would be a nuclear bomb. The key difference lies in the size of their magma chambers. While a regular volcano might have a relatively small reservoir of magma, a supervolcano sits atop a massive pool of molten rock, sometimes hundreds of miles wide. Supervolcanoes are rare, but they exist all over the world. Besides Yellowstone, we have the Toba caldera in Indonesia, the Taupo volcanic zone in New Zealand, and the Campi Flegrei near Naples, Italy, among others. Each of these has the potential to cause global catastrophe if they were to erupt at full force. Now, let's focus on Yellowstone. Located primarily in Wyoming, this natural wonder attracts millions of visitors each year. But beneath its beautiful hot springs and famous geysers lies a geological time bomb. Yellowstone sits atop a massive magma chamber that's roughly 37 miles long, 18 miles wide, and up to 7 miles deep. This chamber is what fuels the park's famous geothermal features, like Old Faithful Geyser. Yellowstone has had 3 major eruptions in its history: 2.1 million years ago, 1.3 million years ago, and 640,000 years ago. Each of these eruptions drastically altered the landscape and had far-reaching effects on global climate. If Yellowstone were to erupt today, it could potentially eject more than 1,000 cubic kilometers of rock and ash into the air. This would be enough to bury large parts of North America in ash, with effects felt globally. Now, let's address the elephant in the room, or should I say, the volcano in the park. There's a lot of misinformation out there about Yellowstone, often fueled by sensationalized media reports and misunderstanding of geological timescales. First and foremost, let's debunk the myth that Yellowstone is overdue for an eruption. This idea stems from the observation that there have been roughly 600,000 to 800,000 years between major eruptions. But volcanic systems don't work like clockwork. They don't follow a schedule, and the time between eruptions can vary greatly. Dr. Janine Krippner, a volcanologist at the Smithsonian Global Volcanism Program, puts it this way: volcanoes don't work on timescales. They don't have a schedule. The complex interplay of geological forces means that past behavior doesn't necessarily predict future eruptions. It's also crucial to understand the vast difference between geological and human timescales. When we talk about Yellowstone being due for an eruption, we're thinking in human terms. But for a volcano, a few thousand years is barely a blink of an eye. So, if we can't predict when Yellowstone might erupt based on past behavior, how do scientists keep tabs on this sleeping giant? The answer lies in a comprehensive monitoring system that's been in place for decades. The Yellowstone Volcano Observatory, a partnership between the U.S. Geological Survey and several universities, uses a variety of tools to monitor the volcano's activity. These include seismometers, which detect earthquakes. Yellowstone experiences thousands of small quakes each year, most too small to be felt. These provide valuable data about the movement of magma beneath the surface. GPS stations measure ground deformation. As magma moves and pressure changes underground, the surface can rise or fall slightly. Precise measurements can detect these changes. Gas monitoring stations analyze the composition of gases released from the ground. Changes in gas composition can indicate changes in the magma system below. Thermal sensors track changes in heat flow from the volcano. Unusual heating or cooling patterns can provide clues about magma movement. All this data is continuously collected and analyzed, providing scientists with a comprehensive picture of what's happening beneath Yellowstone. And so far, the news is reassuring. There are no signs of an imminent eruption. While the chances of a massive eruption are slim, it's natural to wonder, what if? What would a Yellowstone supereruption actually look like? In the event of a full-scale eruption, the immediate vicinity of Yellowstone would be devastated. The initial blast could send rocks and debris flying for tens of miles, but the real danger would come from the ash. A supereruption could send ash clouds tens of thousands of feet into the atmosphere. This ash would then spread, potentially covering much of North America in a layer of ash ranging from a few inches to several feet deep. The global effects could be severe. Ash in the atmosphere could block out sunlight, leading to a phenomenon known as a volcanic winter. This could cause global temperatures to drop, potentially leading to crop failures and food shortages worldwide. To put this in perspective, the 1815 eruption of Mount Tambora in Indonesia, much smaller than a potential Yellowstone eruption, caused the year without a summer in 1816, leading to widespread crop failures and famine in parts of the Northern Hemisphere. While Yellowstone gets a lot of attention, it's not the only supervolcano we need to be aware of. In Indonesia, we have the Toba supervolcano. Its last eruption, about 74,000 years ago, was the largest known explosive eruption on Earth in the last 25 million years. Some scientists believe it caused a global volcanic winter of 6-10 years and possibly a 1000-year-long cooling episode. In New Zealand, we find the Taupo supervolcano. Its last eruption, about 26,500 years ago, was the world's most recent supereruption. Today, it forms Lake Taupo, a popular tourist destination. In Italy, the Campi Flegrei caldera, located near Naples, is another potential supervolcano. Its last major eruption was in 1538, but it's been showing signs of unrest in recent years, prompting close monitoring. While the probability of a supervolcano eruption in our lifetime is extremely low, the potential consequences are severe enough to warrant ongoing research and preparedness efforts. Scientists are continually developing new technologies to better understand and monitor these massive volcanic systems. From more sensitive seismic arrays to satellite-based observations, our ability to detect precursors to eruptions is constantly improving. On a personal level, while it's not necessary to prepare specifically for a supervolcano eruption, general disaster preparedness is always a good idea. This includes having an emergency kit, knowing evacuation routes, and staying informed about potential natural hazards in your area. On a global scale, scientists and governments are working together to develop response plans for large-scale volcanic events. These plans include strategies for managing ashfall, protecting critical infrastructure, and mitigating potential climate impacts. As we've seen, supervolcanoes like Yellowstone are both awe-inspiring and potentially terrifying forces of nature. They remind us of the raw power that lies beneath our feet and the dynamic nature of our planet. But knowledge is power. Thanks to ongoing scientific research and monitoring, we're better equipped than ever to understand and prepare for volcanic hazards. While we can't prevent a supervolcano from erupting, we can work to mitigate its effects and build resilience in the face of natural disasters. So the next time you hear a sensationalized headline about Yellowstone or another supervolcano, remember the facts we've discussed. Appreciate the beauty of these geological wonders, but trust in science to keep a watchful eye on their slumber. Thanks for joining us on this journey into the heart of Earth's geological giants. If you found this video informative, please give it a thumbs up, share it with your friends, and don't forget to subscribe for more deep dives into the wonders of our planet. Until next time, stay curious and stay informed.